and we are going to start a new topic area today. It's going to be much more representative of the flavor of the questions that we're going to do for the rest of the course. Linear systems are great. We'll talk about why in a second. But they're atypical in terms of numerical methods in that they have a very deterministic way to, if I have an equation, I can solve it. So actually, just to reinforce that, we've been solving this kind of thing. Hey, x minus 4y, I know there's a process where if I take 2 times this row and subtract, I'll get 0x minus something y equals something. And we'll get a solution. We'll get y equals really fast. We've been solving linear systems, but as we saw last class, we were solving them with x, y, z, a, b, c, and whatever your next favorite 100,000 numbers or letters for variables are. Huge, huge systems of equations. Monstrous. And the nice thing is, because it's linear, we get a guarantee. Assuming the determinant is not 0 or close to 0, we have some guarantees. There is a solution. It is unique. There is one solution and one solution only we need to find. And there is a process, an algorithm, that will find it for us. So as soon as we put things into a linear equation format, if that's the way they turn out mathematically, there is an answer and we can find it, and there's only one answer. This might seem like something that's obvious to state, but remember, when we contrast it with nonlinear equations, these things are not generally true with equations. If we look at nonlinear equations, there may be no solution. X squared equals -1. Maybe no real solution. There's other things that have no solutions whatsoever. There may be multiple or an infinite number of solutions. So examples would be x squared equals 4 gives us +2 and -2. Or you could have sine of x equals 0. That has 0, pi, 2 pi, 3 pi, 4 pi. An infinite number of solutions. And what else we got? Even if there is a solution, there is no guarantee we can find it. Yay! We're making progress here. We're going into territory that's going to be so much more interesting, if not easy. And just if you're solving these things by hand, you can compare the difference between solving, hey, linear, divide by the coefficient, 10/5. Linear equations are super easy to solve. This one, ln of e to the x maybe is ln of x plus 5. X equals what? I don't know. Already you get different kinds of feelings, hopefully, emotional responses, looking at these nonlinear equations and looking at linear. Linear is, bless you, you're easy to solve. Nonlinear, yeah, we'll see how it goes. There are a lot of nonlinear equations you've looked at in your life, whether you recognize it or not. Let's take this example here first, x squared plus 2x plus 3. How would you solve that? Let's actually change to a minus, make it easier. How would you solve that equation? Through factoring, exactly. It's a polynomial, so we could factor it into x minus 3, x plus 1, sorry, and we'd get that. And once it's factored, we get the roots popping out. So polynomials, nice. Though not as nice as linear. This was a cooked example. The coefficients were nice. It's a quadratic. You know how to handle quadratics pretty easily. If I'd given you the 10th degree, it might have taken a little longer. But at least there's something we know about that. How would I solve log base 10 of x equals 3? Yeah? Each side to the base 10. Absolutely. Put a 10 underneath here. As long as you do the same thing to both sides, you manipulate the equation. The x and the log base 10, or the 10 and the log base 10 cancel, and you get 10 to the 3 or 1,000. All right. So that's using log rules. Fantastic. Ideas for this one? Sine something equals cos of the same thing? Yeah?
Just going to take a stab at it. We can square both sides and then change
Ooh.
one of them into the other.
Square both sides, because then you get sine squared plus cos squared, or you can do some kind of fancy stuff there. That might actually work. Yeah, that's not the one I was thinking of, but if you do that, you do have to worry about adding solutions because you squared things, and sometimes that changes positive and negative solutions around, but sine squared of 3x is equal to 1 minus sine squared of 3x. And then, yeah, so you'd have 2 sine squared of 3x equals 1. And, yeah, you could do that. Then how would you go for that next stage? So I'd have sine of something equals something. That's much better than what we started with. What would you do next? Because we haven't got x equals yet. We're close, but not quite. Yeah. Root both sides? Okay, sure. I was worried more about the sine, but you're absolutely right. You can take care of the square root as well. So sine of 3x is root 1/2. Okay, so once we get it to there, it's not too bad. Actually, it's quite nice. But after that, your calculator will give you something here. If you do this in your calculator, say inverse sine of root 1/2, it'll give you one value. But how many solutions are there to this? Infinite number, lots, yeah. Because the sine graph repeats itself. And what we're asking is, the 3x is sort of the input, changes the frequency. But at the end of the day, we've got this root of 1/2 here. We're looking for all these intersections. All these intersections. So that we can solve, but we'd have to make a pattern. We'd have to sort out exactly what we wanted to represent it as. And of course, there'd be solutions down here at the back end too, the negative side. So, and we'd have plus or minus here. So there's a whole bunch, there's a bunch of work right there. This, again, compare and contrast with, hey, 5x equals 10, or 5x plus y equals 10. Those are simple. This thing, we have to dissect. We can solve it, but we have to dissect the problem type and then do some manipulations. These are also ones that are cooked up, and they're ones you've seen because there are solutions for them by hand. There are also lots of equations we've been hiding from you, like this. Instead of making it equal cos x, if we just make it equal x, how can you solve for x there? You can't. You can try. I mean, by all means try. But one of the things you could do is do arc sine, do the inverse sine. But then you get an arc sine of x on the right-hand side. And so you get 3x equals arc sine of x. I'm not sure that's any better. With that kind of form, there's just no way to move all the x's to one side and isolate x. It's just, there's no way to do it. Same thing with this kind of multiplication here. I can't get x equals by manipulations. There's just no way. Of the equations that exist in the universe, most of them are probably going to be like this if you just design them randomly. The ones you've encountered so far in your life are mostly like this. The ones that have ways to be solved by hand, because those are the ones that we're able to solve by hand. So we kind of like the, I lost my car keys while you're looking under the street lamp. I lost them over there, but I can at least see under the street lamp. I can figure something out with these problems, whereas the problems that we're often more interested are this type, and we so far haven't had tools. What we're going to do is solve these problems today. Start solving these problems today. What I would like to remind you, though, is that we're going to have to settle. I love these equations here, the ones we can solve by hand, because we can solve them in general. We can put parameters in instead of numbers. We can actually solve them in the general case. We get lots more insight. Everything that we do to solve these harder equations is going to be a very, very fancy, educated version, smart version, but at the end of the day, it's guessing and checking. Try a number. How close is it? Check another number. Check another number. It's always going to be approximate. It's always going to have this potential to go wrong. There's a whole pile of reasons not to do this unless you have to. So the one piece of advice at this stage is look at an equation when you're facing it. Ask yourself, can I solve it by hand? If you can, solve it by hand, because it's better. There's all sorts of advantages to doing that. And only if you can't, resort to these numerical methods. The numerical methods are the second choice.